Hi, Alan Stratton from Woodturns. Last night at our club meeting we had a wood exchange raffle. I got this piece that appears to be a very hard wood, but in inspection of the ends it is horribly checked. I was about to throw it away, but well, I'm going to try. Let's see if we can get something out of this very cracked, split piece of very hard wood. So, let's try.
This is such a short chunk of wood and with so many cracks that there is no wood to spare. To square it off somewhat, I'm taking a slice off the worst end on the bandsaw. The wood clamp is for safety and stability. Otherwise, the wood is likely to rotate with the initial blade start and create an exciting event that I'm not likely to appreciate. I also do not like blood on my saw. I also glued a piece of scrap to both ends that my drive and live centers can bite into without losing any more wood. From the smell of the fresh cut, I believe this wood is cherry. Now the wood is mounted between centers. At this point, I've decided to turn this into a sphere, but first I need to rough it down to a cylinder. My bowl gouge is my choice for this task. Others may use a spindle roughing gouge, but I prefer not to have special purpose tools. The point with either is to cut into side grain rather than end grain. Once I have a cylinder, I can trim back the ends to give a good flat top and bottom to the cylinder. The cracks are as bad as I thought from looking at the ends. Now that I have a good cylinder, I can calculate the distances to find the octagon inside this cylinder. With a diameter of 2.5 inches, then 2.5 times 0.293 is 0.732. This is the distance from any corner of the cylinder to the closest corner of the octagon hiding inside. Also, 2.5 times 0.414 is 1.035. This is the length of each side of the octagon. But I am not quite ready to make the marks on the cylinder. I'm doing double duty. One is to cut a tenon on the tailstock's end. I will also size this to the octagon side so that I can use it a bit later as a mark on the cylinder's end. Now that I have a nice corner on the cylinder, I can measure the overall length of the sphere, which is the same as the diameter. Then I can cut a tenon on the headstock end. Again, double duty. Its diameter is the same as the size of the octagon's side. Again, I will use it a bit later when I cut a diagonal. I take a moment to mark the remaining corners of the octagon, then proceed to cut a diagonal, which is another side of the octagon. This diagonal is from the mark on the side of the cylinder to the corner of the tenon. This happens to be 45 degrees, but I do not need to measure the angle since I have the two corner marks to guide me. Then, the same as on the headstock end. When each side is cut, I proceed to reduce the two tenons to about half of what they were. They have served their purpose. Now to make a pencil mark on the approximate middle of each side. This cuts each side in half, pencil only. Then split the side again into quarters. On the tenons, they are now half size. I will guess for the quarter still embedded in the tenon. After all that pencil marking, I cut the corners between the lines. There should be 8, but a couple are hidden in the tenons. Immediately I round off the hexadecagon into a sphere by eye. This is approximate. No precision needed here. Then cut back the tenon even more. This is about 1/8 away from the sphere so that no wood fibers will tear out from within the sphere when the nubs separate from the sphere. I mounted a cup chuck on the spindle and trimmed just a little. With all those nasty cracks, I needed to be a good match. With the tenon nubs now at the equator of the mounted sphere, I can trim initially with a spindle gouge. These are gentle cuts to smooth out the nubs and variants from the perfect sphere. I try to leave the old equator line that is now running from pole to pole. With it now more smooth, I mark the equator again and rotate the sphere 90 degrees. Any tool will do here. I want either shear cuts or scraper cuts. One more rotation at a minimum, but I decided to take even one more since it is a bit rough. Moving to sanding using the exact same approach. Mount, sand, rotate, mount, sand, rotate, mount, sand, and rotate. That is 3 rotations for each grit from 80 to 400 grit. By now, I have changed my mind. Instead of the sphere, this will be a Christmas ornament. I cannot hide those nasty cracks. I may as well try to take the sphere even further. If I cannot hide the cracks, I will feature them. But for a moment, I need a 3/8" hole for a finial. I wrap stretch wrap around the sphere and the cup chuck so that I can drill the hole. With the sphere back between the cup chuck and the end, I'm using a Proxxon cutter to widen the cracks. May as well emphasize them since I cannot hide them. Then switch to a rotary carver to refine the grooves. Then just a bit of coarse sanding to remove any sharp peaks. For a shiny finish, I use rattle can lacquer. For a finial, I chose maple. The initial work is between centers, but I need a tenon before going on. My preference is to work from the tip to the base. I like to keep the live center in place to keep from wobbling. I start with the tip, but leave a bit more to absorb the tip of the live center. For ornaments, I prefer a blunt tip. This is much safer since children like to play with Christmas ornaments. I also want finials for ornaments to be thicker to prevent breakage by, who else? The children. Then work from the tip forming each section. I do not sand each section since I still have tailstock support. Once complete, I can sand the entire finial and make the burn marks near the tip before separating the tip from the live center. Then a final sand of only the tip, and it is ready for shellac finish. However, I need to drill a hole for the top finial. Cracks into the bottom hole preclude a good hold there. So, how to mount for drilling. The bottom finial is glued into the sphere. I use it to gently grab the finial. This is adequate for drilling. The only problem is that I did not hold the chuck while withdrawing the last time. That broke the drill, but I was finished anyway. Now for a loop to hang the ornament. I despise big hardware hooks. This is 22 gauge craft wire, about 3 inches long. It is wrapped around a 3/8" drill, reversed into a chuck. I grasp the 2 ends with vice grips and twist it moderately tight. Then clip to length and use CA glue to anchor it in. Beautiful.
Well, it survived. It calls to mind the story of the ugly duckling. It was very ugly when it was a duckling, but then it grew up into a beautiful swan. Well, my ugly duckling may not be a beautiful swan, but at least it turned into a duck. It evolved as I went. I was initially thinking, okay, I'll just turn a sphere, but then when I finished the sphere, well, there's still those nasty cracks showing up all over the place, so I decided to carve them out with my tools. Oh, okay, that's a little bit more interesting, made it a little bit lighter. Well, why not put a finial on it and a thin wire loop, and, well, now it's a Christmas ornament. And while it may not be the prettiest one on the tree, it is still a nice ornament.
The Christmas Ornament Challenge opens November 1st. See you then. Please give this video a thumbs up, subscribe on my website, and tell your friends about my videos. I appreciate your comments and questions. Every week I add a new wood turning video to my website. Always, please, please, please wear your full face shield anytime the lathe is running. A face shield saved my life, and I regard it as an essential safety measure.